Here's another video of examples of factoring out some sort of algebraic expressions where we have some negative exponents. So we're going to go ahead and we're going to go after the negative exponent. So here we have x squared plus 3 to the minus 1/3 minus 2/3 x squared times x squared plus 3 to the minus 4/3. So what we're going to go ahead and do here is we're going to factor out the lowest power, which would be the x squared plus 3 to the minus 4/3. Okay, and when we factor that, you're going to take each of them the pieces here. So minus 1/3, and we're going to divide that by what we're factoring out. And so what that's going to do is we're going to subtract the exponent. So we're going to do negative 1/3 minus negative 4/3, and that's going to give us negative 1/3 plus 4/3, which is going to give us 3/3, which is 1. So this whole thing is just going to become x squared plus 3 to the first power after we factor that out. Okay. So out of that first one, we just have x squared plus 3 to the first power. I'm going to go ahead and factor a 3 out, so I have the fraction out in front. Your textbook does something a little bit different, but I like having that out in front. So when we factor that 1/3 out, to compensate, because there's no 1/3 here, we're going to multiply by 3, so that when we distribute the 1/3 back in, we still have that coefficient of 1 there. Then we'll have minus 2, because we took the 1/3 out. The x squared is there, and we remove the entire x squared plus 3 to the minus 4/3 power. So all of that has been removed, and all we're going to do is combine our like terms inside of here. So you're going to distribute that 3 through. So I have 1/3 x squared plus 3 to the minus 4/3. Distributing that 3 through, we'll get 3x squared minus 2x squared, which is x squared, and then plus 9. It looks a little bit different in the back of the book, but this is perfectly good. Okay, so we're going to look at one other example. It's got a little bit more going on. So we're going to factor 1/2 x to the minus 2, 3x plus 4 to the 1/2 minus 3/2 x to the 1/2 times 3x plus 4 to the minus 1/2. So what we're going to do first is look at what we got the same of. So the lowest power of x is x to the minus 1/2. So when I factor that out of this is going to be gone. When I factor it out of the x to the 1/2, when I factor, it's like I'm dividing, so that's going to be x to the 1/2 minus negative 1/2. And when I subtract a negative, that's good, so that's going to be x to the 1/2 plus 1/2, or x to the whole. Okay. Then for the 3x plus 4's, we're going to factor out 3x plus 4 to the minus 1/2, so we'll be factoring that term out. So when we factor that, this part's going to be gone, and we'll have 3x plus 4 to the 1/2 looking at this term. When we divide it by what we're factoring out, which is 3x plus 4 to the minus 1/2, it's going to be just like with the x's to the minus 1/2. We're going to subtract our exponents. We're going to be left with 3x plus 4 to the first power for this term right here. For the fractions, we have a 1/2 in common, so we're going to factor out a 1/2. So we factor out a 1/2. For the x to the minus 1/2 and the x to the 1/2, the lower power is minus 1/2. For the 3x plus 4, the lower power is 3x plus 4 to the minus 1/2. Okay. For the first thing, we have removed the 1/2, we have removed the x to the minus 1/2, and we just had the discussion of 3x plus 4 to the 1/2 divided by this, and that gives us 3x plus 4 just to the first power. So we just did that. So that's what we got left there. We removed the 1/2, so we just have 3. And we just had the discussion of x to the 1/2 divided by x to the minus 1/2. That was just x. So we're going to have a 3x there. And then finally, when we factor out the 3x plus 4 to the minus 1/2, that's going to eliminate that term there. Okay, we're going to clean up inside here. So we're going to have 1/2 x to the minus 1/2, 3x plus 4 to the minus 1/2 times 4. And then 4 times 1/2. 4 times 1/2 is going to give us the 2. And that's all we got going with that. There's not a whole lot more we can do with that.